C# records. What are they? How do I use them? When should I use them? Hello world, I'm Nick Proud, and in this video I'm going to be talking about C# records, specifically how they differ from classes and structs, how you implement them, and how you can choose to use them in your projects. But before we get into that, don't forget to like and subscribe to the channel for more .NET content. Let's get into it. So what are records? Well, records were introduced in C#9 as a reference type, which is an alternative to classes or structs. Records were originally only reference types, but in C#10 there was the introduction of record structs. So now you have the choice between record classes and record structs. What records allow you to do is create an immutable reference type. So an object, a reference to something with members that doesn't change, it's immutable. You can technically make mutable records, but I'm going to focus on the original design of records, which is this more static, immutable object. Records give you the benefit of a variety of specific features, for example, value equality. For example, if the values of two records of the same type are the same, they'll be evaluated as equal, which differs from classes, but more on that later in the video. But overall, records provide you that ability to have a reference of immutable data with built-in functionality for encapsulating that data. So one key question that I want to answer in this video before we get into the demonstration is, how do they differ from classes or structs? Well, records are specifically designed for that immutable data. And like I said, you can make them mutable, but the primary design was for immutable data. Records give you that kind of struct-like functionality with built-in functionality which differs from structs. So for example, one of the biggest differences to structs is that records can use inheritance, whereas structs can't use inheritance. They can only implement interfaces. They also differ from classes in that they have a built-in functionality for extension methods like toString. So if you do a toString on a record, you'll get the record name and its contents. Whereas if you do a toString on a class, you'll just get the name of the class. So the overall theme is that records blur the lines between classes and structs in a way that make it a little bit more focused when it comes to more static, although that's probably not the best keyword to use here, but data that doesn't change. So first of all, let's look at an example of how we create a record at a very basic level. So as usual, I've got my demo console project here with a main entry point, and above that I'm going to create a record. So I'm going to make it public, and I'm going to call it public record employee. So the type of record is employee, and now I want to give it some members, and I can do that very simply by just passing in parameters. So I can say that employee accepts a string called name and a string called title, and then closing it off with a semicolon, and I've created a record. So that's the very basic way that you can create a simple record in C#. And you can go a step further if you like and define it in a way that looks a little bit more like a class. So you could open this up and you could create some properties. So I could say public string name get, can't find the semicolon, there we go, get set, and public string title get set. So that would also be fine. Now while this is fine, most of the time I opt for the original way because it's just easier for me to see how it's created, and that I can create it in a way that takes parameters. So I prefer personally to do it this way because it keeps it nice and simple and it's very light. So I know that I can say that my var employee1 equals new employee, and I can say that it's Nick and his title is developer. So nice and simple. So let's look at one of the first built-in features for records, which I think is one of the most powerful aspects of it, which is the value equality. So I'm going to create a second employee. So employee2 equals new employee, and this employee is going to be called Sarah, and she is an IT technician. Yeah, so that's her title. Okay, so we would expect these to be different in the sense that they're both employees, but the values are different. So employee Sarah is not the same as employee Nick. So we can test this out by saying employees are the same, which is equal to employee 1 dot equals employee 2. So I would expect this to be false. Fairly straightforward. If we run that, then we can see that that is indeed false, even though the types are the same. Now if I go ahead and change this so that Nick becomes Sarah and these values are identical, so IT technician, then I would expect this to be true, which it is. Now, does this work for classes? Well, let's take a look. So if I was to create an employee as a class, then we can do the same comparison. So outside of this, I'm going to say public class, and I'll just call it employee class. Then we'll set our properties. So we'll have a public string name, and we'll have the same thing here with title. Okay, so I'll also give it a constructor as well, just so that I can create it in a similar way to the record. So public employee class, so it takes a string of name, and I'll just use the IntelliSense there. So we've created our constructor, passing in the name of the title, and then it will initialize those values there. So then we need some instances of that class. So I'm going to say employee class 1 equals new employee class, and I'll do the same thing here. I'll just put the same parameters. I'll copy that. We'll call it employee class 2, and then we'll evaluate these. So employee classes are the same equals employee class 1 dot equals employee class 2. So I'd expect these two to be equal, so employees are the same is true, and then we're going to see what the equality is for two classes with the same values. So as we expected, employee records are the same, but if we look at the employee classes, it says false. Now why is this? Well, this is because value equality works differently for classes than it does for records. So even though the values are the same, they're not technically the same because they're not referencing the same object. So this can be a bit of a problem when you're dealing with information that you want to compare. If you've pulled a record from one source that in theory has exactly the same data for a record in another source, you'd expect to be able to just evaluate them as true when comparing them. But if those two things are classes, technically they're not true because they're separate objects. So that's one of the benefits of records, is that you can compare them, and as long as the values are correct, as long as the values are the same between the two records, it will evaluate as true in equality. Now, it's important to note that that only works when it comes to the records being the same type. So if I created another record with identical properties called colleague, then it wouldn't evaluate as true because the records are actually different. So there is a limit there. Another nice feature of records is the built-in toString functionality. So you may have done toString on a class before and seen that you just get the name of the class or the type of the class back. Whereas with records, there's built-in functionality to not only give you the name of the record, but also to give you the values inside it. So we'll do a toString on a class so you can see what I mean. So I'll say var class toString equals employee class 1.toString. So we'll have a look at what that is, and then we'll have a look at the same thing for an employee record. So employee 1 string. In fact, actually, let's just change that to record to string equals employee 1.toString. There we go. So we'll take a look at these. So running that through, if we look at the class to string, you can see that it gives you the namespace and then the class name. So that's default behavior for toString on a class. Whereas if we do the same thing on the record, we get something slightly different. So we get the employee, which is the name of the record type. Then we also get the information for the record's values. So we can see the name is Sarah, the title is IT Technician. It becomes super helpful when you want to just take the content and just dump it into a text file. It makes it so that it's designed for you to get the data out as soon as possible. So another really cool feature about records that I mentioned at the beginning of the video is the fact that records allow you to use inheritance. So structs don't allow inheritance. They do allow you to implement interfaces, but with a record, you can inherit from another record. So let's have a look at that. So if we create another record, so I'll say public record department, we can make it so that any employee has a department. So we'll say string department name, and then I'm also going to give it a second value, but I'm going to initialize that value to something from the start. So I'm going to say string, and you can use other data types, by the way. I know I'm using a lot of string parameters, but I'm just using strings for this example. I'm going to say string location, but I'm going to say that it's equal to UK. So I already know by default parameter, that the location is UK, unless I set it to something else. But I just want it to be initialized to a particular value. So we've got our department. It would help if I spelt department right. And now we want employee to inherit from department. So for this, we simply put our colon as we would for inheritance on classes, and then we say department, and we pass in the parameters for that record on its constructor. So we can take the department name from the employee. So we just add the parameter for the department into the employee. So it's like passing through to a base class. In fact, it is pretty much the same thing. So we can say string department name, and we'll use that in our department's base record. So we pass in department name from the constructor on employee. Close that off, and now our employee records inherit from a department. Visual Studio is now complaining because we haven't given an argument for the required parameter department name. So we can easily fix this. We can just put IT. And I'll just put this on this one as well, just to keep things happy. Okay, there we go. So now if we create an employee record passing in the department name, that will go through to that base record. I'll run this, and I'll just hover over employee 1, and you can see if we look at the properties, we've got the department name as well within the employee record. And also that location that we set on the department record is showing up in the employee. So that's also quite useful if you've got relationships between records that you need to enforce. Now, one thing I have noticed, which I don't know if it's me, but you have to be careful of, is if you have names of properties between records that you're inheriting from that are the same. So by that I mean, if you had a property in department that's just called name, and you also had one called name in employee, what I've noticed is using this method, it tends to overwrite with the latest added value. So I'll show you what I mean. So if I change the department's department name to just name, and we still pass through that department name, but it initializes name here in the department, watch the effect. So if I run that again and then hover over employee 1, you can see the department name is IT, which is correct, but the name is also IT. So it seems that you've got to be very careful about conflicting property names. So whenever you're inheriting from a record, make sure you don't have properties in the derived record that are named the same as the base record, because they can clash. So now we've learned how to create records and how to use some of the built-in functionalities that come with them. But when should I use a record? Well, the clue is in the name, really. When you're using data that is like a record that would say sit in a filing cabinet for a long time without being changed, and you may have to grab that file and compare it with another file that's been sitting in another filing cabinet somewhere. So it's for more static data. Again, I keep using that word, which is probably not the best word, but it's for data that is unlikely to change, and you may need to pass that data around. So you may want to use a record as a DTO. You have to weigh up whether structs would be better than records, or whether a class would be better than records. But if it doesn't need to have functionality, if it just needs to be passed around and looked at, then a record is probably a good shout. They bring the benefits of structs with more functionality, and they make comparing immutable objects really straightforward. So for me, they sort of blur the lines between classes and structs a little bit. And they're a fairly new feature, so if you're used to using structs, you may just stick with that. But I'd encourage you to at least give records a go. And if you do find them useful, let me know in the comments below. I'd love to hear. But that's everything for this video today. I hope you found it useful. If you did, then don't forget to like and subscribe to the channel if you're not already subscribed. And I'll see you next time for some more .NET content.